Hi, I'm Ninjak and I'm a junior in college, and there's a copy of this worksheet and the answer key in the description. So this is arc length, which is basically when you have a graph and you're trying to figure out how long part of it is. And if you're taking AP exams, this is just a BC topic, not an AB topic, but it is an easy BC topic. So there are 3 formulas, but they're very similar. It's just based on whatever the givens are. So for the first one, you use that when y equals f of x some function. And I write times x, but I actually meant times d of x, which I fixed later. And for the second one, it's super similar, but you use it when x equals g of y of some function. And for the third one, you use it when you have parametrics. So basically, you just have to take the derivative and set it up, and you're good. And for this, it says use a calculator to find that exact length, but you don't have to because I'm just going to tell you the answer anyway. But on the AP exam, when you do have to use a calculator, round it to 3 places after the decimal. So for the first one, the derivative is just chain rule, and then you just set up the formula. And you get 10.541. And my estimation sign looks weird, but we're going to pretend like it doesn't. So for this one, it's a little harder derivative, and you use a second formula for the arc length. So the derivative is x equals ln 3 minus 2y to the 1/2 plus 2, which is it turns into 1 over square root 3 minus 2y, times technically 1/2 times 3 minus 2y to the negative 1/2 times negative 2, but that combines into that second part, which equals negative 1 over 3 minus 2y. And then you just plug it into the formula. And you get around 2.184. So for the third one, for the derivative, use the power rule. And for the integral, you can technically just leave it the way it is that I have it at first, but for the second version, I just took the 6 out. So that equals around 20.361. For the next one, you have to isolate it before you take the derivative. So that's what I do at first. So first you isolate x, and then you take the derivative of x. Then you just plug it into the formula and you get this, which is around 7.526. So for this one, dy over dx is 3 times negative cosecant x squared times cotangent x squared times 2x, and 2x comes from the chain rule, and that first part with the cosecant and cotangent is like a formula you have to know. And then you plug that into the formula and you get around 10.144. So for number 6, for the derivative, you have to know the a to the x rule. So the derivative is 4 to the 2 ln y times ln 4 times 2 over y times 1 over y. Then after you plug it into the formula, you get around 20.163. So for number 7, dy over dt equals 1/3, which is pretty easy, and then dx over dt is the product rule with the chain rule for the negative. Then you just plug it in and you get around 0.704. So for this one, you're basically doing dy over dt, except instead of t you use theta, so it's dy over d theta. But it's basically the same thing because you use the same formula. So you plug it in and you get around 4.443. So for the next part, on the AP exam, on the free response section, you're not going to really get questions with the words arc length. It's going to be more like find the perimeter of this region, and that's when you have to use arc length. So it basically, like, it's not going to be the full thing using arc length, but you're just going to have to find a section of it using arc length. So that curvy side here is where you have to use arc length to find the perimeter. So there are 4 sides here, 2 vertical and 1 horizontal, and the curvy side. So the curvy side is just what you use the arc length formula for, and then this is just, the length of it is just the x coordinate, which is 1. And then for the other two vertical sides, you have to plug in the x coordinate into the function to get the y coordinate, and then that will be the length. So for the left side, you plug in 0, you get 1, that's the length. For the right side, you plug in 0, or you plug in 1 and you get e squared. And then that's how you get the full perimeter once you add it up. So this one has 3 sides. There's a line, there's a curve, and there's the vertical side. So you have to use 2 integrals because this line isn't vertical or horizontal, but it's not hard still. So you still find out this. So you plug in 2 for both functions because you have 2 functions, and you get 6 for the top and you get -4 for the bottom, but you can't really add those together because you're trying to find the perimeter, so that's why it becomes positive. And then you use the arc length formula and you get around 20.971. So that's arc length.